So in this problem, we're going to express P as an affine combination of U, V, and W. And right now we can express P as an affine combination of S and R, and then we can express S as an affine combination of U and W, and then R as an affine combination of V and W. So if we figure out S and R first, then we're going to be able to express P as an affine combination of these three. Alright, so for part A of the problem, let's start by expressing R as an affine combination of V and W. So R is equal to 4V plus 2W over 6. And 6 comes from the fact that it's a 6-unit line. And you can see here that the coefficients all add up to 1. So 4 plus 2 is 6, divided by 6 is equal to 1. And also, V is given more weight because R is closer to V. So I'm just going to simplify this a bit. Now another way of thinking of this is taking one of these points as a starting point of the line, so we'll take V, and then add some multiple of the line VW to get to R. So we're adding some multiple of the line VW. So as you can see here, R is 1/3 of the way along this line starting at V. And our line VW can be expressed as W minus V. So let's just expand that and then simplify. And as you can see here, it gives us the same result that we found earlier. So it's the same as up here. And you can take W as a starting point and it would give you the same result. So now we'll find S. So vector S can be expressed as 5U plus W over 6. And again, we have more weight given to the U vector because it's closer to S. Now what we want to do is we want to express P in terms of S and R. So P is equal to 2S plus R over 3. And you can see here that S is given more weight because it's closer to P. Now we know our S and R in terms of U, V, and W, so we're going to sub those two in now. So we have 2 times S, which comes from up here, and then we have our R, which comes from over here. And that's all over 3. Now I'm just going to multiply 2 by this term here, and that's going to make our bottom 3 instead of 6. And I'm going to add these two terms together and then multiply the bottom and top by 3 to get rid of the bottoms here. So we end up with 9 on the bottom. So now we have P expressed as an affine combination of U, V, and W. And as you can see here, the coefficients all add up to 1. We have 5 plus 2 is 9, divided by 9. Now the next part of our problem is to use this result here to deduce where the line UP extends to meet the segment VW. So let's just draw our line UP to begin with. So there's our line UP, and now we want to know where it extends to hit this line. Now there is a line along which V and W are all given equal weights. So that line would start at about the midpoint of VW. So let's name that midpoint Z. So if z is the midpoint of the line VW, then the affine combination will be equal to a half V plus a half W. So now if we look back at our P, we see that V and W have equal weights here as well, which means that P must lie along that line where V and W have equal weights. So let's extend that line. So we can see here that if we extend the line UP, it hits the midpoint of the line VW, which can be expressed as Z equals a half V plus a half W.